In Module 3, Lesson 7, we're going to work with 6 facts and 7 facts, and we're going to apply all the strategies that we've used so far with multiplication and division to solve those problems. So we're going to use a letter to represent the unknown. That's called a variable. We might use the distributive property. We might use the commutative property. And we might use tape diagram or um, any other strategy that we've learned so far this year. So we're basically, it's a chance to apply everything that we've learned so far to a new set of facts. The 6s and the 7s are the new ones that we're learning, and this lesson gives us the opportunity to solve some of those problems with those numbers using all the strategies that we have picked up so far in 3rd grade. So let's get started with that right now. So let's just review here for a moment about using a variable. Again, a variable is just when you use a letter to represent what you don't know in a problem. So for example, 6 times some number equals 30. So we've written it like this in the past with a blank. We've written it like 6 times question mark equals 30. Now what we're doing is we're going to write it with a variable. So we'll say 6 times b equals 30. And then that b, we have to figure out what that is to make this number sentence true. So the only number that can fit in there to make 6 times some number 30 is 5. So b equals 5. And that means anywhere there's a b, we're going to replace it with a 5. We could replace it with a 5 to say that 6 times 5 is 30. So that's one thing I wanted to review here before we get going. And then we might have a problem. You'll have some practice with identifying sort of those. So you'll practice where it's like again 6 times b equals 30, and on one side, and then you'll have like you'll have different solutions on the other side here. So you might have 5, 7, 10, 9, 6, and then you might have other problems here as well. And you're going to eventually pair them up and say that those two go together. And then you might have 60 equals 6 times a equals 10. So you'll have that sort of practice today as well. And then you're going to get into word problems, and that's where the bulk of our work comes today, is where the word problems. So let's dive right into that next. So let's see, we might have a problem that says something along the lines of Jimmy has, let's see, 7 packs of pencils. He has a total of 42 pencils. How many are in each pack? And with that, you might also have to write an equation with a letter to represent the unknown. So let's start doing that. So the first step would be to write that equation to represent the unknown. So there are a bunch of different ways we could do that. I'm going to say 7 times p for pencil equals 42. You could have also written 42 divided by 7 equals p. Either one of those is fine, depending on if you want to think of this as a multiplication or a division problem. And then you could go ahead and solve it. Again, there are a bunch of different ways you could do that. Some of you may want to draw a picture and say, I have 7 packs. So you might draw 7 packs. And again, this strategy totally works, but it's one that we're trying to start to move away from because we want to become more efficient with our multiplication strategies. And then you could start saying, 1, 2, 3, 4, 5, 6, 7, 7, 10, 14, and you'd keep going and going and going until you got up to 42. Now, as you could see, I got to 14 and I was already like, okay, I'm taking too much time on this strategy. So you could see that this sort of strategy, especially as we get to larger numbers, is going to take a long time. So it'll work, and you'd eventually find out that there are 6 in each. So that's one way to do it. Another way to do it would be to draw a tape diagram, because we know that there are the same number of pencils in each pack. So again, we know the total is 42. We know that there are 7 packs, so each unit here, each box is going to be a pack. 1, 2, 3, 4, 5, 6, and 7. And then we need to figure out what that is. That's P. We need to figure out what the size of P is. Um, we could count by sevens. We could count by, we count by sevens. See how many times we had to do that. So 7, 14, 21, 28, 35, 42. I counted by 7 6 times. So P must equal 6. And I'm sort of running out of room here, but let's try one more strategy. We could do a number bond. We know the total is 42. We know that there are 7 groups. And then again, we could use that same count by strategy there. See how many times we had to count by 7. It's 6 times, which means each group is 6. So there's again, you're not going to have to solve it necessarily 3 different ways, but I want to show you that there are a bunch of different ways to solve problems like this. Is a little bit of a review. And again, the strategies haven't changed. What's changed is the fact that we are using different sets of numbers with the strategies that we already know. Now let's go ahead and look at a different problem. Let's see. So Gabriella has, we're going to stick with the writing utensils here in our problems today. So Gabriella has 24 markers. She has 6 in each pack. How many packs does she have? Write an equation with a letter to represent the unknown, then solve. All right. So step 1 says to write an equation with a letter to represent the unknown. So we can do that a couple of different ways. Again, we can say that she has, we could do a division problem. 24 markers divided into 6 packs equals, or 6 markers in each pack equals the number of packs she has. I'm using M for markers. You could write 6 times M equals 24. Either one of those works just fine. Again, notice that M in both cases is just standing for the thing that we don't know yet. We call it a variable. That's a big word. Really all it means is the thing that you don't know. So we have to figure out what number can go in there and make this true. So when we put something in there in place of the M, when we replace the M with a number, whatever number we put in there has to make this sentence true. This one is interesting because I'll tell you up front the answer is 4. And that's interesting because we've already learned our 4s. Many of us have already worked on those. And so this is a turnaround fact from that. So you may already know this, and that's what we talked about a few lessons ago, is that you can use facts that you learned previously in some of the other fact families or other times tables rather, and you can use those to figure out facts that we're learning now. So just because we're working on our 6s doesn't mean that we need to learn all the 6s, because you already learned, 6 times 1 when you worked on 1s, and 6 times 2 when you worked with 2, and 6 times 3 when you worked with 3, and in this case 6 times 4. But for a minute, say you've forgotten that, we could break this into, let's see, I could have, we'll do a number bond here, 24, and I know I have 6 markers in each, so 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. And we found out that we had 4 groups there, right? So this is a similar problem to the one we just did, but a little bit different in that last time we knew the number of groups, and this time we knew the size of the groups. And that just plays out a little bit different when you create your number bond in this, and it will when we do the tape diagram down here as well. So again, I know that I have a group of 6, and I know that all my groups of 6s together are going to add up to 24 or multiply to 24. So 6 plus 6 is 12, plus 6 more is 18, plus 6 more is 24. So we find out that m equals 24. Okay, so you might think to yourself too, there's a different way to solve this, and you might say, well, I don't know what 6 times something equals 24, but I know that 5 times 4 equals 20, right? And then I know that 1 times 4 equals 4, and I know 20 plus 4 equals 24. So this is another way that you can solve it. You can take that 6 fact and break it into a 5's fact, because 5's facts are really, really handy. They're really useful. And so basically what you're saying is 6 times 4 equals 5 times 4 plus 1 times 4. And you're solving it that way. Now you got to have a pretty good idea of what's going on in this problem to use a strategy like that. You have to understand that you could break a 6 into a 5 and a 1. You have to understand that to get from, you kind of have to already sort of know where you're headed with your answer, because you kind of have to know that like 20 plus 4 is going to be 24, which means you know already that you're working with 4 groups. But it is a useful strategy to be able to break apart and solve that way. It's especially helpful if you, we'll do one like this in a minute, but it's especially helpful if you don't know the product yet. So let's do one of those. This will be our last example here of the day. All right, so we have Mr. Burnell. Let's see, what did I do? I was folding laundry. I folded 4 piles with 7, we'll say 5 piles. No, I'm sorry, no, we won't. Folded 6 piles with 7 shirts in each. It's a lot of laundry. Write an equation with a letter to represent the unknown, and then solve. All right, so this one's a little bit different. I'm going to say I have 6 piles with 7 pieces of clothes or shirts in each, and then I have a total of this many C clothes. So C is my unknown. Okay. I could write a division sentence this way too, but it doesn't help us as much in this case. So in this case, I'm going to stick with the multiplication sentence. Now, instead of doing 6 times 7, this is where it's really helpful to use a 5 fact. So I might say 6 times 7 is the same as 5 times 7 plus 1 times 7. Okay. And by doing that, I can now say, well, I know my 5 fact, that's 35. And I know 1 times 7 is 7. So now all I have to do is add 35 and 7. So I took a fact that I probably didn't know as a 3rd grader, but I broke it into two things I did know. And I can add those together really easily and find out that C equals 42, because 35 plus 7 is 42. C equals 42. I could have done that a different way. I'll do it in I'll do it in a different color for you here. I could have broken the into 5 groups and 2 groups with working with a 7 instead. So I could have done 6 times 7 is the same as 5 times 6 and plus 2 times 6. Right, so I have, again, I have a total of 7 shirts in each. So here I'm showing 5 and 2, which adds up to 7, and my 6 stays the same all the way along. So that equals 5 times 6 is 30, 2 times 6 is 12, 30 plus 12 is still 42. So again, I could have broken it up either way. This way, the first way, I think is easier, especially as you're learning the strategy in third grade. I think that this is the one that you should rely on more often, but I do want you to know that you can do it this other way as well. So there are multiple ways to approach a problem like this. And as your level of comfort increases with this first way, I'm sure that we'll be able to move into expand a little bit into that second way as well. All right, guys. I'm happy that we are back from our winter break, and I'm happy to be back into multiplication division here. You guys are doing an awesome job, and I'm really proud of you. So let's keep up the good work here in Module 3.